So this lesson is on how to write formulas for covalent compounds or molecules and how to name molecules. It should be a lot easier to tackle than ionic bonding was, which is a good thing for us. So we'll need our covalent nomenclature practice handout. The first page is writing formulas. The back page is naming them, which is fantastic. Your nomenclature booklet totally has explanations for how we do each one of these processes. Also on the back, you guys, oh my gosh, I'm so great. I even gave you a list of what those Greek prefixes are. So if you forget what the Greek prefix for 7 is, you can look back here and be like, okay, good, that is good for me to know. You do not get this nomenclature booklet on your test, but it is definitely useful, especially when we start getting into this, to have this handy. Okay, so let's totally see. And I'm also going to use my blue colored pencil because we know that covalent compounds are made up of non-metal, so I'll be doing blue things in each one of these, which is super exciting. But covalent is actually super easy. I'm just naming, and these are only for what's called binary covalent compounds, meaning I will not ask for you to name or write a formula for something that has multiple nonmetals in it. Just 2 different elements that are nonmetals making up this covalent molecule, okay? But, so out of the 2 things that I'm going to name, the second element's ending will change to "ide." We've seen that before in ionic naming. But here's the trick here. It says, do not reduce ratios of subscripts. You guys, we know that my molecules, they're all stuck together. I cannot be like, okay, some of you hydrogens and some of you oxygens go away because we're going to get the lowest whole number ratio. No, there's not a ratio involved here. It's a molecule. Okay, it's got a distinct number of all of the atoms involved here. Okay, we know we can reduce my ionics because it's got that crystal lattice, that extensive structure of cations and anions, and all I just need to know is how many of each ion relative to each other you have. But here I do not reduce ratios of subscripts for my covalent, and that is different than my ionic naming rules. And then I've got these things called prefixes, you guys. The prefixes literally represent how many of each atom you have in your molecule. Mono, do you see how it says you only use mono for the second element? If there is one of the second element, that's when you use mono. If there's one of the first element, no prefix for that. We'll get to some examples when we get down here. But for every other amount, we are going to use a prefix: di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. Okay, so here we go. It says provide the compound formulas corresponding to the following compound names. Okay, so here in each one of these things, you will see 2 words that represents the 2 different elements involved. Hopefully I've only given you nonmetals here, but let's kind of see, just to check to make sure that I've given you only blue things from our colored periodic table. Let's see, carbon, yep, he's blue. Tetra, don't worry about it, he's a prefix, tetra. Chloride, oh, chlorine, so I've just got a compound with carbon and chlorine. Di, oh, that's a prefix, don't freak out. Hydrogen, yes, he is totally a nonmetal. Monoxide, oxygen, okay? So everything down here, if you wanted to take all the time, you could totally see that I've only given you blue things to name for me, which means, yes, we are doing our covalent nomenclature rules here. Okay, so now, y'all, this is so fun. All we have to do here is just look at what the prefix tells us, and that's going to tell us what subscript we have. So coming in hot here, I've got carbon. It does not have a prefix. So once again, for the first element, if there's only one of them, you will not start off with mono, and he does not have any other prefix in front of him besides that. So we only have 1 carbon. The symbol for carbon is C. That is it. But then I've got tetra. Tetra up here. That means 4, you guys. So how many chlorines do I have? Cl4. So carbon and then chlorine with 4 of them. Next one, this one's going to be super fun. Di. Di means 2. Hydrogen. So that means I have 2 hydrogens. Now we see the mono here. So we only use mono if there is one of the second element. And I have 1 of that second element, which is oxygen. Now, most people do not, like, it is so lame to call dihydrogen monoxide when it is really water. So you will probably get used to, in my class, when you see water, we say water, okay? And you'll see that a lot in chemistry when we write our own chemical reactions. If a chemical reaction is involving water, I will say water in that chemical reaction. I will not take the time to write out dihydrogen monoxide because that is kind of ridiculous. Okay, next up we have nitrogen. No prefix, so there is only one nitrogen. Trihydride. Tri means 3, but hydride. High. Remember, we always change the ending to the second element to ide. So try to dissect what element is hydrogen. And it is, in fact, hydrogen, and I have 3 of them. I will let you know that a common term for NH3, nitrogen trihydride, is actually ammonia. Okay? So if you see in my class ammonia, it is understood to be NH3. And you're like, oh my gosh, she's having me just know these things off the bat. No, that's basically the only one that I will not go and do the full nomenclature technical name for. I just wanted you guys to show y'all that because that is super cute and super fun. Okay, I'm going to do maybe a couple more. I'm going to do a couple more is what I'm going to do. Let's see, because this is real fun. Let's do some bigger numbers. Let's go number 7 down here. Hexaboron monosilicide. Okay. Try to dissect where the nonmetals are in here. Okay. Boron. Cool. Boron. He's definitely a nonmetal. Hexa. Hexa means 6. Yes. And then I have mono, which means one of who? Silicon. So Si. So B6 Si. I do want to mention the one right above it is I have antimony. And antimony, y'all, you're like, what is going on? Sabaka, he is totally right on here. And yes, he is. But if I give you a formula where there's clearly Greek prefixes here, then he is acting in that weird metalloid nature as he is right on the staircase. It's not very common that he makes covalent bonds, but he does have that ability. You're like, well, how am I supposed to know whether it's ionic or covalent? Well, the naming rules are different for ionic versus covalent. And when I see this tried, I'm like, okay, those prefixes are only used for my covalent. So he is making a covalent bond here. I feel like a lot of us maybe would not even notice that, but I did want for some of us, if we were like blasting through this, being like, oh, wait a second, he's a metal, which yeah, technically his metalloid characteristics are popping out there. Anyway, I only have one antimony, so that'd be SB, and then tribromide is bromine, so BR3. Now, keep in mind, we also said this thing of like, I am not going to reduce my ratios to my subscripts. Let me show you a couple of examples on those. I've got this one, number 20, tetraphosphorus decoxide. So tetra means 4, dec means 10. One thing to notice here is a lot of times if the element is oxygen, since oxygen starts with a vowel of O, sometimes the ending of the prefix, like of the A's, kind of get dropped. I will not count it wrong on your paper if you write decaoxide because I see that you understand the concept, but just do not freak out if you're like, how am I supposed to know where to shorten the things? Okay, it's just because oxygen starts with a vowel, it makes it a little bit more condensed and less, word blah, 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 coming off of your tongue. So I have tetraphosphorus, which means I have 4 phosphoruses, and I have 10 oxygens. Now, normally if this were an ionic compound where I'm only interested in knowing the ratio of each ion to each other, I would be reducing that down. I would divide 4 and 10 by 2 to get a 2:5 ratio. But I cannot do that in these molecules. In this molecule, they all stuck together. I got 4 phosphoruses and 10 oxygens all together. I cannot give you a lowest whole number ratio. I've got to give you what is actually in that molecule. Same thing for this one down here. I've got disulfur, dichloride. So I have 2 sulfurs and 2 chlorines. Cannot reduce that ratio to a 1-to-1. If I looked at this molecule, it's literally got 2 chlorines and 2 sulfurs stuck together. Okay. So that is, luckily that's not too tricky. We've got Greek prefixes for my writing formulas. All I have to do is figure out what the prefix is and how many of each that is, and that's my subscript. Okay. Now we're going to do the opposite, meaning I'm going to give you a formula and you're going to name it for me. Y'all, the rules are basically the same. There's not a lot of explanation going on here on my covalent naming or my covalent writing formulas, which is why when you look in these books, pages on this side, you don't see quite as many explanation that was required for my ionic, which is kind of a good thing. The main thing, and that's why I wrote this in here up on the top of each one of my doors on the covalent side, is that Greek prefix things is your kind of home base, your foundation. So I literally look at how many I have, and I use the prefix to represent that. The only kind of trippy thing is that I do not say mono for the first element if there is one. So for example, this is carbon. I do not say monocarbon. This is normal carbon. And I have one oxygen, so that I would say monoxide. So you would not say, based on our conversation about the oxygen starting with a vowel, you technically would not say monoxide because that would be a lot of O's, but we would say carbon monoxide. Next one, let's see, I have sulfur. How many sulfurs do I have? I got 2, so this prefix for 2 is di. So I have di, sulfur, right? And then I have 5 oxygens, and I have pentoxide because the prefix for 5 is penta, dropping that A, so pentoxide. Yep. 2 nitrogens, so we got dinitrogen. 3 is trioxide. I feel like we are getting, I don't know how many more examples I want to do of these. Maybe we'll pick one that's got like some real large prefixes. There are not super many examples here. Let's hop on down to do 5 and 6. Let's do 5 and 6. So there are 5 carbons there. So I would say pentacarbon. And then 8 is octa, and that's hydrogen, so octahydride. Octahydride. Not too much space for that. And then I've got 4 phosphoruses on this next one down. So 4 is tetra. So tetra phosphorus. And then 5 is penta. So penta sulfide. Only thing sneaky here, besides just being like, hey, how much do I have of you, is just changing that ending to "ide." I do want to have us look at number 7. You were like, O2, dioxide, which technically correct, but if I've got one of my diatomics, which I know oxygen is, we would just call it oxygen. Okay, and this is me being kind of technical. I do not think I would have on a test or a quiz like me ding you points for just knowing it's oxygen, but this is just kind of a reminder of those diatomics. And our diatomics will start to play a little bit more of a featured role in our chemistry course next unit when we use all of these compounds that we're learning now how to write and name when we do chemical reactions with them later. But I think that is, you guys, I think we just did it. I think we did it. That's pretty simple, right? And once again, I did not fool you on this side. If I wanted to check on my periodic table, yeah, every single one of them are a blue nonmetal. Okay, so this is my covalent. Covalent are all nonmetals. We have written the names with my prefixes telling me how many of each I have. And we have done some formulas using those prefixes to tell me how many of each I have. So pretty straightforward covalent nomenclature rules, which we love. So we did it.